In the last chapter, Chapter 2, Technology Infrastructure and the Internet, you recall that we were discussing how important the Internet is in facilitating e-commerce and e-business. Well, in this chapter 8, web server hardware and software is a continuation of that, because remember we said the Internet is the technology infrastructure, the pipes that carry all the data. Well, the web servers are the hardware and software that transmit the web pages. So this is the next layer that makes e-commerce and e-business possible. So let's see. Okay, this slide actually is a direct continuation from what we talked about last time. If you remember, we talked about protocols, and we talked about the TCP/IP protocols that enable web servers to use those software protocols to turn web addresses, web pages into packets and send them. And we've talked about something called platform neutrality. Well, this is kind of a nice visual where regardless of what kind of system you use, whether you're on a PC or a Mac or smartphone or a tablet or anything, they're all using those same TCP/IP protocols we talked about to turn the data into packets, to send it on the web, and then by extension all the different types of servers that we'll talk about in this chapter also use that same TCP/IP protocol so that they can read and respond to these packets and use the same consistent protocol. And that's what platform neutrality is. And because of that, that really is huge in making the web a seamless way to transmit data. Okay, so let me go as usual and start with a couple of videos. This one it's not the best, but it's not bad. It's just sort of a basic short video on what are web servers.
Web servers are computers that are usually set up in facilities called data centers and operated by hosting companies. The purpose of these computers is to store websites so that people can visit them on the internet. The files stored on web servers are read by browsers, which convert these files into images and text for you to view. Your browser communicates with the web servers to bring you information from the internet. Web servers communicate with many browsers on many computers all at the same time. Their purpose is to serve files as requested. A server can send the same file or different files to hundreds of users at the same time. Many factors go into determining how many files a web server can handle at once. Server hardware plays a role in this when comparing how fast the server processor speed is to how popular the site is and how many views it has at once. Provider Spider has multiple server options to fit every need. Web servers typically run two types of operating systems, Linux or Microsoft Windows. Most web servers today operate Linux, and most websites are hosted on Linux servers. Servers with Linux or Microsoft Windows installed on them also run other key software programs similar to your home computer. These software programs are called daemons, and they run in the background rather than in the direct control of the user or person viewing the website files on the internet. Confusingly enough, these software programs are also referred to as servers themselves. So you must distinguish if servers means hardware or the software run on them, based on context. As an example, here are some daemon software which run on nearly all web servers. Web servers also run other software programs which are installed on them. These programs too run in the background, but are accessed with usernames and passwords to protect them. Such software programs can be very useful and helpful in creating websites. These and over 150 more software programs are all free with any hosting plan at Provider Spider.
Okay, so obviously that was a commercial, but I did a lot of searching, and that was really the best simple web server explanation video I could find. And so the idea that you saw is that there's, server, the name server is used both for the hardware, so that, the actual computer hardware that processes the requests, and that has to do with speed and processing speed, the number of requests it gets, and so on. And then it also refers to the software that actually runs the web server. So we will get into that, but I just want to show you a very quick example of Google, which is probably one of the biggest web server farms. So here's a good one.
Whenever you use a Google product, you're connecting to one of our data centers around the world. Let's take a look inside and see how they work. Google employees work here, keeping the data center up and running 24 hours a day. The networking room is the first stop on our data center floor. The equipment here routes requests to the right servers in the next room. These computers also allow our data centers to communicate with one another globally. On the server floor, powerful computers handle everything from billions of searches to hosting YouTube videos and protecting your email against viruses. We've custom designed these servers to be compact and energy efficient. To ensure you have access to your data whenever you need it, we keep each piece of data stored on at least 2 servers. We store another copy of the most important data on digital tapes. When a hard drive breaks, we erase all of its content. Then, for extra security, we destroy it with our disk crusher. The machines in our data centers are always working. Cooling towers like these pipe in water to cool them down and keep them running. When the water heats up, we pump it back outside where it evaporates. Now that you've had a glimpse, walk inside yourself. Explore a Google data center with Street View.
Okay, I thought that was a pretty cool video to just give you an idea of what these data centers look like. And they also reiterated that there's different types of web server software. You notice that they mention email servers, they mention web servers, and then the other very common one is a database server. So I hope that helped. And before I go back to the PowerPoint, let me show you this here. So when you're looking at web servers, what should you be looking at as a manager? And so stability, I mean, we've all had the experience where our systems crash. You don't want that to happen. If you're Google and you've got millions and billions of requests per second, you don't want your system to crash. Security, of course, that goes without saying. It should be easy to administer. It shouldn't be very, well, it's complex, but it should be easy to administer. It should have good features. Should be able to integrate with other software, and it should be scalable. That's really important, scalable. Okay. All right, let me go back now. Okay. All right, so we talked about what is a server, and we talked about the different meanings of server. And actually, let me show you a nice visual here. So, okay. A server uses something called the client-server architecture. And what that means, in the most simple form, a 2-tier client-server architecture means that, let's say you're on your laptop or on your desktop or on your smartphone or whatever, you type in www.amazon.com. What you're doing is you're sending your HTTP request on the web server through the internet using the TCP/IP protocols that we talked about, and then that gets sent to the Amazon web server, which processes your request, sends it back through the internet, and then serves you the landing page. So that's pretty simple. We all know that, and that's what we've been doing when you've been creating your HTML files and sending them to the main business school server. That's very simple 2-tier client-server architecture. And this client-server architecture is really what makes it what makes e-commerce and e-business work. And so you'll see, well, here it just breaks it down. Don't need to get into that right now. But the way the World Wide Web works is that you get into more complex client-server architectures. So 3-tier and above. As it goes 3-tier, 4-tier, 5-tier, and then you just call it N-tier. But this one's interesting. So let's say you're requesting something from LL Bean. You're on your laptop. Let's say you send a request to LL Bean. It goes through the internet. It goes to LL Bean's web server. And let's say in your request you're checking on bean boots. And you know how actually, okay, so well, sorry, wait, let me go back here. What it's going to do is it's going to use then a database server software and send a request to the inventory database and do a query saying, do you have these bean boots in a certain size and a certain color? And then it's going to come back and send you the data back to the web server. And then, if my cursor would work, which is, there we go. So you send it back here, then that will send your request back, and you'll come up with the web page showing the LL Bean boots and the size and so on. Well, then let's say you decide to purchase it, so you send in your you click the purchase, it sends that web information through the internet to the web server, but then it's going to use server software to send it to the order fulfillment and processing system, which are other applications. And so this is all client-server architecture based, and again, this is what makes e-commerce and e-business work, this client-server architecture. So it's kind of important to do that. So, all right, let's see. This is what I was going to show you. Let's just say that we come to LL Bean. So this was a simple 2-tier, right? We just requested a landing page. But now, if I go into footwear, let's go into women's. And so now I've sent another request. This is 2-tier architecture. But now if let's say I click on these rubber bean boots. Okay. So I'm sending a request for another page. But let's say I want to say, I'll just arbitrarily pick, let's pick a size 8, let's pick a medium, and let's pick a color. All right. So now what's going to happen is we're going to get into a 3-tier architecture. When I click on add to bag, it's going to send my request first to the web server, but then it's also going to it's also sending a request behind the scenes to that database server to check to see if it's available and in stock, and then coming back serving this page saying, it is in stock, because if it wasn't, we'd get a little notice saying, sorry, we're currently out of stock. And so if I were to check out, which I won't, but then we would be sending a request to send data to, as we talked about, the order fulfillment and accounting, order entry, all that kind of stuff. So it gets very complicated with N-tier architectures. Okay, I hope that makes sense. Okay, all right, so that's client-server architecture. Now, what about operating systems? There's basically 2 major operating systems that are used, usually Microsoft or Linux. Unix is usually for huge, powerful supercomputers, so you won't see that too often. But let me get out of this for a second here and go back in here. Okay, we talked about that. So you can, oh, sorry. Oh, wrong one. Okay. Going back to here. Okay, so how do you know what to choose? How do you know whether to use a Microsoft operating system or a Linux system? Well, these server systems kind of run things just like your operating systems run things. Oops, sorry. Darn. Okay. But how do you know which ones to consider? Well, Microsoft server operating systems. Usually you would, if you have what you call a Microsoft shop, you're using all other Microsoft products, then by default it usually comes with it and it's compatible with all your other Microsoft software. So that's what people do. A lot of businesses now use Linux. The University of Maine uses Linux because it's open source, meaning that it's free, although you do need to have a technical IT support staff to install it, to maintain it, to fix it. But it's very, very commonly used. Okay, and again, Unix you don't see very often. Now, so that's the operating systems, which run all the behind-the-scenes things, like bringing up files and load management and stuff like that. But then we're web server software that actually receives the request for the software and then sends it back, processes and serves it back. Again, there's a couple of very common ones. And let me go back here now. This is what I was going to show you before, this one. Apache and Microsoft are the two major ones. And if you look on the key here, Apache, this is just over time. You can see it ebbs and flows. It's interesting. I don't know why it's down so low. Usually it's considered one of the best ones. And look at that, as of August of last year. So this is as recent as they go for this reporting. Apache's way down and Microsoft is way up. I can't explain that. It'd be interesting to do a little research on it, because usually Apache is usually way up and Microsoft is way down, but then you can see the other ones are lower. So the two main ones is Apache and Microsoft, and the same rationale. If you're a Microsoft shop, you're going to get the Microsoft server, IIS server with it, and Apache usually run if you're running Linux. So they kind of come bundled as a pair. Going back to server software, this is just a kind of a fun site. If I did www.umaine.edu to test the speed, and oops, oh, that's weird. www, let's see, try it again. So let's do llbean.com. Let's try that one. Okay, so they're looking at the capabilities of LLBean's server software. Okay, let's see what we got here. Performance grade of 74. That looks pretty good. 2.94 seconds. Load time faster than 54%. The page size we requested was that amount. So look at that. Tested from Stockholm. That's pretty interesting. Sweden. Okay, so they're basically saying LLBean's got pretty good performance. It looks like they could use improvement, but the thing is, this 203 requests, I assume that's like per second, so that we were requesting the LLBean site same time as many other people, so the performance will ebb and flow depending upon how many requests they get at any certain time. And so when you're looking at hardware and software, you want to look at how much traffic, how many web requests we think we're really going to get, and we need to kind of plan in the performance, the speed, the size into both the hardware and the software. All right. Okay. So Apache, all that. Okay. Okay. So again, if you're looking at hardware, there's all kinds of many companies out there, as you HP, Dell, lots of other ones. Here's, just like in that Google video, here's what a big server farm would look like. Blade servers, but they keep evolving, so that's something that you would just do some research on. Green computing, Google's really big on that because computers use huge amounts of power, and so if you can find servers that don't use that, or if you can use virtualized servers or mesh servers, then you can reduce your energy consumption and contribute to less pollution of the environment, because all that electricity emits huge amounts of carbon into the environment. Okay, and then the other thing you want to look for is things like how fast does it process web pages, which is called the throughput, the response time, how much time is required to process one request, and so on and so forth. So all just factors to keep in mind if you are charged with finding or purchasing either the hardware or the software. So we talked about client-server architecture. Server farms like Google has are huge data warehouses full of these servers, as we saw in the video. Centralized architecture is where you spread it around. So basically, you get to one web server and you centralize all your processing requests, as opposed to a decentralized or distributed one where it goes to a router and it spreads the load, which I assume is a lot more efficient than the centralized version. And then they also have these load balancing systems. So here's one where web page requests come in, it goes into this load balancing switch, and then it distributes it based on the capacity of the different servers and processors. And of course, with cloud computing, a lot of this process is going to dedicated server farms that will take care of this for you. So it's something to consider as well. And then the last thing is simply wanted to no, not that. Wanted to show you this website just as a resource. It's called ServerWatch. So if you're charged with purchasing or replacing your server hardware or software, this is a pretty good website that looks at different emerging systems, and you can find all of those specifications that we talked about. Okay, that's it for now, and I look forward to seeing you in the discussion forum.